Now let's solve some of the gate problems. So I am now taking the problem which is asked in year 2010. So gate AME 2010. So I am writing the problem here first. A moisture sample has tri-bulb temperature. Sample has tri-bulb temperature. Tri-bulb temperature of 30 degrees centigrade and specific humidity and specific humidity humidity of 11.5 gram water water vapor per kilogram of dry air per kilogram of dry air. Assume molecular weight of air. Assume molecular molecular weight of air is 28.93. If the if the saturation vapor pressure of of water at 30 degrees centigrade is 4.24 kilopascal and the total pressure and the total pressure is 90 kilopascal, then find the relative humidity. Find the relative humidity of air sample. Of air sample. So now let's solve this problem. So first of all, I am writing the things given in the problem. This tri-bulb temperature is given 30 degrees centigrade. Specific humidity, that is denoted by W, that is given 11.5 gram vapor per kg of dry air. So in terms of kilogram, 11.5 into 10 to the power minus 3 kilogram vapor per kg of dry air. Molecular weight of the air is given, that is 28.90. Saturation vapor pressure, that is PS, is given 4.24 kilopascal and total pressure, that is atmospheric pressure, is given 90 kilopascal. So now we have to find out relative humidity. So specific humidity is given. So we know the specific humidity is 0.622 PW divided by P minus PW. So specific humidity 11.5 into 10 to the power minus 3 equals to 0.622. PW we have to find out. P we are having 90 kilopascal minus PW. So we are getting 0.0185 90 minus PW divided equals to PW. So 1.665 minus 0.0185 PW equals to PW. So on further simplification, I will get 1.665 equals to 1.0185 PW. So PW will be 1.635 kilopascal. So I am having the value of partial pressure of water vapor, that is 1.635 kilopascal. Now we are interested in relative humidity. So relative humidity equals to phi equals to Pw by Ps. So Pw I am having 1.635 and Ps I am having 4.24. So it is coming 38.56. So it is coming 38.56 percentage. The correct answer is 38.56 percentage. Now let's take another gate problem which is asked in gate 2008. So I am writing gate ME 2008. So first of all I am writing the problem. Moisture at a pressure of 100 kilopascal is compressed to 500 kilopascal and then cooled to 35 degrees centigrade in an aftercooler. The air at the entry to the aftercooler the air at the entry to the aftercooler is unsaturated and becomes just saturated at the exit of the aftercooler. At the exit of the aftercooler. At the exit of the aftercooler. The saturation pressure of water. The saturation pressure of water. The saturation pressure of water at 35 degrees centigrade is 5.628 kilopascal. The partial pressure of water vapor of water vapor in the moisture entering the compressor is close to 8.57 kilopascal, B 1.13 kilopascal, C 2.26 kilopascal, or D 4.52 kilopascal. Now let's solve this problem. So I am giving the solution for this problem. In that problem, assume the compression is isentropic. So I am assuming compression is isentropic. So now I will draw the process on TS diagram. So here I am drawing the process on TS diagram. On y-axis I am taking T On x-axis I am taking entropy. Here I am drawing the two pressure curves. One is at 500 kilopascal and second one is at 100 kilopascal. So now according to the problem, before entering into the aftercooler, the air is unsaturated. Suppose we are compressing from 1 to 2. So here if you see at 2, that is unsaturated air. I will write here that is unsaturated air. And here if you see it's a constant pressure pulling in after cooler. So after exit from after cooler it is saturated. So here we are having saturated air. So I will write saturated air. So now from this diagram it's very clear. Here 2 is unsaturated here and 3 is saturated here. And if you see here the pressure, if you see P2 and P3 are on the same pressure line. So I will write P2 equals to P3 because it's a constant pressure pulling. And if you see P1 and P2, so we can get this ratio. So now I can write P2 equals to 5 times P1 because P2 pressure line is 500 kilopascal and P1 is 100. So the P2 is 5 times P1. So similar way I can rearrange P1 equals to P2 by 5 and we know P2 equals to P3, so it is P3 by 5. So now P1 we are having for P1 for now we have to calculate for T1. Now in problem it is already mentioned the saturation pressure of water at 35 degrees centigrade is 5.628 kilopascal. So we have to use 5.628 here and if we divide this thing with 5 we will get P1. That is the partial pressure of water vapor entering the compressor. So that is P1. So it is coming 1.13 kilopascal. So the correct answer will be 1.13 kilopascal. Now let's take another interesting problem which is asked in year 2008. So I am writing Get ME 2008 problem. Air at dry bulb temperature. Air at dry bulb temperature. Dry bulb temperature of 40 degrees centigrade and wet bulb temperature of wet bulb temperature of 20 degrees centigrade is humidified in an air washer operating with continuous water recirculation with continuous water recirculation recirculation. The wet bulb depression the wet bulb depression the wet bulb depression, that is the difference between that is the difference between dry and wet bulb temperature. Dry and wet bulb temperature. Bulb temperature. At the exit is 25% of that at the inlet. That at the inlet. The dry bulb temperature. Now find the dry bulb temperature. Dry bulb temperature at the at the exit of the air washer. Exit the air washer. So now we have to find out dry bulb temperature at the exit. So now let's solve the problem. So first of all, for this problem, I will draw the process on the psychrometric chart. So here I am having the psychrometric chart here. On this axis I am having humidity. On this axis I am having dry bulb temperature. So according to the problem, the humidification is occurring, and this humidification is occurring with the help of air washer that is operating with continuous water circulation. So this one is the process where cooling and humidification both are occurring. So now I will draw the cooling and humidification process. So that is from 1 to 2. So 1 to 2, that is humidification and cooling process. And remember one thing, this 1 to 2 I am putting on constant wet bulb line. So here that is wet bulb temperature is constant. So now at one point we are having the dry bulb temperature 40 degrees centigrade, and at 2 point we are having the dry bulb temperature that is T dry bulb 2. So we are having T dry bulb 2. But if you see 1 to 2, that is a constant wet bulb temperature. So at 2 also the wet bulb temperature is 20 degree, and 1 also the wet bulb temperature is 20 degree. So I can write wet bulb temperature at 1 and 2 point will be same, that is 20 degree centigrade. So now according to the problem, the wet bulb depression, the difference between the dry bulb and wet bulb temperature at exit. So at exit, the difference between dry bulb at exit dry bulb is dB2, and the wet bulb we know the same, that is 20. Is equals to 25% of at that inlet. So the 25% of inlet. So inlet we are having dry bulb temperature at inlet, dry bulb temperature at inlet minus wet bulb temperature, that is 20. If you see dry bulb temperature at inlet, it is 40 degrees centigrade. So now T dB2, that is dry bulb temperature at exit minus 20. 25% means 0.25. Dry bulb temperature at inlet 40 minus 20. So T dB2 minus 20 equals to 0.25 into 20. So T dB2 minus 20 equals to 5. So T dB2 equals to 25 degrees centigrade. So the correct answer, that is dry bulb temperature at exit, will be 25 degrees centigrade. Now let's take another problem which is asked in GATE 2007. So I am writing the problem which is asked in GATE AME 2007. Atmospheric air atmospheric air at a flow rate of 3 kg per second on dry basis on dry basis enters a cooling and dehumidifying and dehumidifying coil with an enthalpy of with an enthalpy of 85 kilojoule per kg of dry air and a humidity ratio of 19 grams 19 grams per kg of dry air 19 grams per kg of dry air. The air leaves the coil the air leaves the coil with an enthalpy of 43 kilojoule per kg of dry air and humidity ratio and humidity ratio of 8 grams of 8 grams per kg of dry air 8 grams per kg of dry air. If the condensate water if the condensate water if the condensate water leaves the coil with an enthalpy of 67 kilojoule per kg, find the required cooling capacity find the required cooling capacity of the coil in kilowatt. So now we are interested in the cooling capacity of the coil. So now let's solve this problem. So I am just giving the solution for this problem. We have already discussed in theory for cooling capacity of the coil. For cooling capacity of coil, we are having one formula, that is G H1 minus H2 minus W1 minus W2 HF2. So for here in this formula H1 we are having 85 kilojoule per kg and H2 is 43 kilojoule per kg. W1 we are having 19 into 10 to the power minus 3 kilojoule per kg of dry air and W2 we are having 8 into 10 to the power minus 3 kilogram per kg of dry air and HF2 we are having 67 kilojoule per kg. So now the cooling capacity of coil, that is Q, equals to G, we are having 3 H1, that is 85 minus 43 minus of 19 minus 8 into 10 to the power minus 3 into 67. So Q equals to 385 minus 43, that is 42, minus of 19 minus 8, 11 to the power minus 3 into 67. It is coming 0.737. If we subtract with 42, it will come 41.263, and if we multiply it with 3, we will get 123.8 kilowatt. So the required cooling capacity of the coil will be 123.8 kilowatt. So now let's take another problem which is asked in GATE 2006. So GATE ME 2006. So I am just writing the problem here. Dew point temperature is the temperature at which condensation begins when the air is cooled at constant A volume, B entropy, C pressure, and D enthalpy. So it's a very straightforward question. So according to the dew point temperature, it is the temperature at which the condensation begins when the air is cooled at constant pressure. So the correct answer for this problem is C, pressure. Now let's take another problem which is asked in GATE 2006. So I am writing the problem which is asked in GATE 2006. The statement concerned psychometric chart, psychrometric chart. Number 1, constant relative humidity lines are uphill straight lines to the right. Straight lines to the right. Second, constant wet bulb temperature lines are downhill straight lines to the right. Downhill straight lines to the right. Third point, constant specific volumes lines are downhill straight lines to the right. Fourth option, constant enthalpy lines enthalpy lines, constant enthalpy lines are coincident with constant wet bulb temperature lines. With constant wet bulb temperature lines. Temperature lines. So now, which of the following statements are correct? Now, which of the statements are correct? A 2 and 3, B 1 and 2, C 1 and 3, and D 2 and 4. So it's again a straightforward question, and in psychometry chart we have already defined all the lines, that is constant volume lines, constant enthalpy lines, constant wet bulb temperature lines. So if you see the option 2, that is constant wet bulb lines are downhill straight lines to the right, that is correct one, and the constant specific volume lines are downhill straight lines to the right. This one is also correct. So from given options 2 and 3 are correct. So the correct option is A, 2 and 3.